In this video, I'm going to explain negative exponents because they might be the most counterintuitive idea in mathematics. Exponents tell us that we're supposed to repeat multiplication by a certain number of times that the exponent tells us. But how would we multiply something by itself, a number that's negative times? I'm going to explain all of that to you right now. So the first example that we're going to go through is a base of 2. Then we'll go over a base of 3, and then we'll take a look at the general base of a, so that we'll be able to simplify all of our expressions that have negative exponents in them. First, we have 2 squared. That's just 2 times 2. And we have 2 to the first power. That's just 2. And we have 2 to the 0 power, which in my previous video I explained is 1. In order to get this pattern, all we're doing is dividing each row by 2 to get to the next row. So I divide by 2 to get to this row. I divide by 2 to get to this row. That's logic, that's math. We're going to keep dividing by 2 because that makes sense. We're going to divide 1 by 2. That gives us 1 over 2. Looks good. Let's go at it again. And remember, we're going to continue the pattern. We're dividing by 2. So we're going to divide 1/2 by 2 now. And that gives us 1 over 2 to the second power, positive second power, because we divided by 2 again. One more time, we're going to divide 1 over 2 squared by 2 again, and that's going to give us another 2 in our denominator, or a third 2. Hopefully you're seeing how these two numbers relate to each other. But let's just take a look at 3 to make sure that 2 isn't some kind of crazy example, and then we'll do a to make sure that those aren't crazy examples. All right, 3 is just 3 times 3. Divide by 3 to get to the next row. Also, we know 3 to the first power is 3. To the 0 power, we divided by 3 again to get that 1. We're going to keep dividing by 3 to get to the next one. That's 1/3. Now we're going to divide by 3 one more time. We divided by 3 again. That's 1 over 3, the second power. Then we're going to divide that by 3 one more time. And that gives us 1 over 3 to the third power. I think we're noticing that the exponents become positive and we just put them in the denominator. That's what it's looking like. Let's take a look at the general case. A to the second power is just a times a. That's not an a. A to the first power, that's just a. Again, we're dividing by a to get from each row to each row, but right now we're just using our definitions that we know. Anything to the 0 power is 1, but the pattern still holds. Now we're going to go into our negative exponent. We need to divide by a again. 1 divided by a is 1 over a. We're going to divide that by a again, and that gives us 1 over a squared. So all of these seem to be pointing at one definition of negative exponents, and that is that if we have any base to the negative power, let's call it our base a and our power negative n, we can rewrite it as 1 over a to the positive n. Now, I know you're not thinking about this now, but you should be. What happens when the negative exponent is in your denominator? Well, this logic of it going to the denominator if it's in the numerator, it holds the other way too. If it's in the denominator, it goes back to the numerator. So this would just be a to the n power, and it just flips back. So in summary, if you have a negative exponent and it's in the numerator, move it to the denominator and make it positive. If it's negative in the denominator, move it to the numerator and make it positive. It's that easy.